Hello friends, this is Vinay from iOS interview. Today we will discuss struct vs class vs actor. So friends, this is very most important topic which is asked in every interview of iOS. So friends, moving further on the video, all I ask is that today you do the best work of your entire life. This is quote by Steve Jobs. So friends, moving further on the video, you did not subscribe my channel till now, then subscribe and like and share. So friends, topics we will cover on this video are introduction, class, struct, actor introduced in Swift 5.5, comparison summary, memory and threads, conclusion. Introduction. In Swift, class, struct and actor are all types that can define properties and methods, but they have distinct characteristics and use cases. Understanding the differences between them is crucial for effective Swift programming. Class. Number one, reference type. Classes are reference types, meaning when you assign an instance of a class to a variable or constant or pass it to a function, you are working with a reference to that instance. Number two, inheritance. Classes support inheritance, allowing one class to inherit the characteristics of another. 3. Reference counting. They are subject to automatic reference counting ARC for memory management. 4. Mutability. Even if an instance of a class is assigned to a constant, its properties can still be changed if they are declared as variable for 5. Deinitializer. Classes can have deinitializers deinit, which are called when an instance of the class is deallocated. 6. Typecasting. Classes support runtime checks and typecasting to check and interpret the type of a class instance. 7. Objective-C integration. Classes are inherently compatible with Objective-C and the Cocoa frameworks. Struct. One value type. Structs are value types, which means when you assign an instance of a struct to a variable or constant or pass it to a function, a copy of that instance is created. Number two, no inheritance. Structs do not support inheritance. 3. Mutability control. If an instance of a struct is assigned to a constant, its properties cannot be changed. Properties can only be modified if the struct instance is a variable. 4. Default initializers. Structs automatically receive a member-wise initializer if they do not define any of their own initializers. 5. Efficiency. Structs are generally more efficient than classes, as copies are only made when absolutely necessary. 6. Use cases. Ideal for small data structures that encapsulate unrelated data where copying or immutability is desired. Actor. Introduced in Swift 5.5. Number 1. Reference type. Like classes, actors are also reference types. Number 2. Concurrency control. The primary purpose of actors is to provide a safe concurrency model in Swift. They allow you to work with shared mutable state in a safe way by serializing access to their mutable state. 3. Isolation. Actors isolate their data, ensuring that only one piece of code can access their state at a time, preventing data races. 4. Asynchronous methods. Methods of an actor are inherently asynchronous to ensure safe access from external context. 5. No inheritance. Like structs, actors do not support inheritance. 6. Use cases ideal for managing shared mutable state in concurrent applications. Comparison summary. Reference vs value types. Classes and actors are reference types, sharing a single instance, while structs are value types, creating copies. Concurrency. Actors are specially designed for safe concurrency, unlike classes and structs. Inheritance. Only classes support inheritance. Memory management. Classes are managed by ARC. Structs and actors don't require ARC since they don't use reference counting. Use cases. Classes for complex data structures with inheritance, structs for lightweight data encapsulation, and actors for managing shared mutable state in concurrent code. Choosing between these three depends on your specific use case, especially considering factors like the need for inheritance, performance implications of value vs reference types, and concurrency requirements. Memory and threads. When discussing classes, structs, and actors in Swift, their behavior in relation to threading and how they are managed in memory, especially heap and stack, are important considerations. Classes, memory allocations. Instances of classes are allocated on the heap. Heap allocation is more expensive in terms of performance due to the increased complexity of memory management and the potential for fragmentation. Number two, reference types. As reference types, when you pass a class instance around in your code, you are passing reference to the same instance. This means multiple parts of your code can have a reference to and modify the same instance. Number three, threading considerations. Thread safety. Class instances are not inherently thread safe. Care must be taken when assessing them from multiple threads to avoid issues like race conditions. Concurrency. Developers need to implement their own synchronization like lock semaphores if instances are shared across threads. Structs. Memory allocation. Struct instances are typically allocated on the stack, which is faster than heap allocation. The stack is more efficient due to the way it stores and retrieves data LIFO, last in, first out. Number two, value type. Structs are value types. When you pass a struct around, you are passing a copy of it. Each part of your code gets its own copy, making it inherently safe from concurrent access issues. Number three, threading considerations. Thread safety. Structs are generally considered safer in a multi-threaded environment. Since they are copied when passed, each thread works with its own separate copy. Performance. Since they are on the stack and copied, they can be more efficient, more performant in single threaded scenarios, but can be costly if the struct is large and passed around frequently. Actors. Swift concurrency model. Number one, memory allocation. Like classes, actors are allocated on the heap. They face similar performance considerations regarding heap allocation. Number two, reference type with concurrency control. Actors are reference types, but they are designed to avoid many of the common pitfalls of concurrent programming. They encapsulate their data and operations, ensuring that no two pieces of code can access the same piece of data at the same time. Number three, threading considerations. Thread safety. Actors provide a mechanism for safe data access in a concurrent environment. They serialize access to their state, which helps prevent race conditions. Concurrency. Swift's actor model abstracts away many of the complexities of thread management and synchronization, making concurrent programming more approachable. So, friends, you can see single thread like heap, register select, register stack code, and this is the thread, and multi-thread, heap, register stack, registers stack code, and this is one thread, and this is another thread. Conclusion. Classes allocated on the heap shared via references require manual synchronization in multi-threading scenarios. Structs typically allocated on the stack copied when passed offer inherent safety in concurrent context due to their value type nature. Actors allocated on the heap provide built-in concurrency control to safely manage shared state in multi-threaded environments. Understanding these characteristics is vital in deciding which to use based on performance needs, memory management, and thread safety requirements in your Swift applications. So, friends, in this video, we try to cover all differences between class, struct, and actors related iOS interview. We will discuss other questions in upcoming videos. This will definitely help you to prepare for your next interview. So, friends, thank you for watching this video. Also, comment below if you learned something new here. So, friends, thank you for watching. Please like, share, and subscribe